Okay, let's see how to use Geogebra and construct a slider crank mechanism. Okay, so the required inputs are, one is L2. okay, let's have that value 3, and the other one is the length of the coupler. Let's have that value as 5, and then eccentricity. Okay, let's have that value as 1. Okay, now let's see, this O2 point is going to be at this origin. Okay, it can be anywhere, but I would like to have it at the origin. And let me change the name to O2. Okay, fine. Now let's say the theta value is going to be 60, so I'm going to identify the point A. Yeah, let me choose some random value and then let me modify this. Okay, but before that I have to, okay, anyway, the length is L2 into inside cos theta into pi by 180, and then sine theta into pi by 180. Okay, but this point A hasn't moved because I haven't defined what is theta. Theta is equal to 60. Okay, right, so now we have A at this position. Okay, now in order to identify B, I need to know along which line that B point or the slider is going to move, right? So that's going to be this line. Okay, that's going to be this line. So I'm going to choose a point. Okay, so let me do one thing. Let me draw a line. Okay, line which is between this point and say this point. Okay, well, that's not B. Why don't we change the name? Let's call that point as, okay, let me change the name of that point later. Okay, now what am I going to do? I am going to draw a line parallel to this line. Okay, so see, there is a parallel line. Click on this. It requires select point and parallel line. Okay, now I need to select a point. Okay, so now I need to select a point. Let's, okay, let me choose the point which is this point. Okay, now how am I going to, so now it's like 0, 1, but it's basically not 0, 1, but it's 0, oh sorry, I have to put, it's just 0, E, right? That's our point C. Okay, now I can draw the parallel line. So the first I have to select the point. So this is the point and this is the line. So now I have this parallel line. Okay, so let me see, and if I change my E value, then this line is going to change. Okay, let me keep this E value to 1. Okay, now maybe let me hide this point C and also this point B. Okay, now what I have to do is I have to draw a circle with A as a center and L3 as a radius. Have we given L3? Yes, I know L3, so I need to construct a circle. So A as a center and L3 as a radius. Say okay. Now if you notice, we have two solutions. One is here, another one is here. I leave this solution as an exercise for you guys, and I'm just going to construct this as a solution. Okay, so let me identify the intersecting point, which is this point. Okay, so that's my intersecting point. And now let me hide this circle, this C. Okay, now all I have to do is I have to construct these line segments. O2 to A, which is linked to A to D, which is link 3. Okay, the coupler. Now let me change the theta value and let's see what's happening. See, and when I change the theta value, I'm getting it like this. Okay, maybe I will change my L2 value to 2 and say enter. Okay, and also I'll change the scale of theta value to 0 to 360 with with 1 as a step. Okay, and also let me make sure that when I slide, it's not going to oscillate, it's going to increase. Now let me run this theta value. Okay, so let me increase the speed. Okay, so that's how we can construct our slider crank mechanism. Okay, and now you could change these values. Let's say, what if E is equal to 0? Let's see. See, that's the configuration for E is equal to 0 and E is equal to 0.5. So that's E is equal to 0.5. Yeah, with that you could play and you could do all the analysis, and we'll do one more thing, the extreme positions, right? So one of the extreme position is, okay, it will come somewhere here. So that's one extreme position. Okay, so that's one extreme position. And at extreme position, if you see, this link 2 and link 3 are collinear. The other extreme position is so that's another extreme position, and once again link 3 and link 2 are collinear, but the angle between them is 0. Okay, the psi value, that's 0. So by measuring the distance, okay, what is the stroke length? The stroke length is the distance between two extreme positions, and that we can identify by knowing what is the distance between the point C, sorry, not that point C and D. Okay, so if we measure the distance between C and D, we have some value. Okay, and maybe it would be nice if I just, okay, and that value is 2.95, and the other extreme position is somewhere this, and at that time CD value is 6.98 or 7, and the difference is the stroke length. Okay, so that's how we could construct the slider crank mechanism with the eccentricity, and we could do the analysis. Okay, and similarly I have constructed a mechanism which is known as a quick return mechanism. Okay, so it's a quick return mechanism, and the reason it's been called quick return is because if you see, this is the forward stroke. The forward stroke is taking long time, but the reverse stroke is coming quickly. Okay, so that's why it's called a quick return mechanism, and in our next video we will see how to analyze such quick return mechanism. But meanwhile, what you could do is you could practice constructing such a quick return mechanism. Okay, thank you.